The exact moment you tap the Enter key, you expect your favorite website to appear on your screen immediately. You see a fully loaded page in seconds. But in the brief flash of time between your keystroke and the screen lighting up, a global relay race is taking place. A website is a collection of physical files. You are downloading HTML documents for structure, CSS style sheets for visual design, and JavaScript code for interactivity. Those files sit on a web server, a specialized, always-on computer designed with the specific job of holding on to digital data and handing it out whenever someone asks. When people talk about the cloud, they are actually describing a vast interconnected network of these physical web servers, working around the clock to push digital files to your device. To see how those files get to you, we have to trace a single request outward from your laptop to the rest of the world. When you type a web address like example.com, your browser creates a formal network request. Computers process data using numbers, so they cannot read standard domain names. When your request hits a DNS server, it enters the domain name system, the Internet's phone book. It translates that human-readable URL into a numerical IP address. An IP address is a unique string of numbers identifying a specific computer. Armed with that numerical coordinate, your request physically travels through fiber optic cables, bouncing across routers until it reaches the specific machine tied to that address. Arriving at the correct destination is only the first hurdle. The real processing challenge begins the moment your request knocks on the server's door. Your request is greeted by specialized web server software, typically a program like Apache or Nginx. These are software applications designed to listen for, manage, and respond to incoming web traffic. This interaction operates on the request-response model. It is a simple two-way communication protocol. Your browser asks for specific data, and the web server gathers it and sends it back. Retrieving static content is simple. The server grabs a pre-written file from storage and returns it. Dynamic content triggers a complex pathway. The web server routes your request backward to an application server and a database, generating a custom file on the fly. Think of the web server as a waiter in a restaurant. The waiter takes your order, but they don't cook the food. They hand the ticket to the kitchen, the application server and database, which actually prepares your specific meal. Once the kitchen finishes assembling your order, the waiter brings it out to your table. In the same way, the web server takes the final assembled files, packages them up, and transmits them back across the network to your device. Your browser catches that package of code and instantly renders it into the visual web page you can read and interact with. In the span of a few milliseconds, the web server has evaluated your request, fetched existing files, or coordinated a complex database assembly line to deliver exactly what you asked for. That single sequence of events happens flawlessly when one person visits a site. But a major global platform like Amazon or YouTube receives millions of these digital requests every single second. In a real production architecture, user traffic flows first to the web server, then the application server, and finally the database. Organizing this way allows engineers to horizontally scale servers to handle traffic spikes and create a secure buffer protecting the sensitive database. Maintaining this flow of traffic requires dedicated IT professionals. Linux administrators configure the operating systems, DevOps engineers automate the infrastructure, and backend developers write the code that retrieves data from the databases. Knowing exactly how to direct a network request, process a digital file, and return it to a user is the foundational skill required to engineer the modern internet.